Hi, welcome to the ComSci 137 lecture. Sunny here. For this module, we will be discussing HDLC and PPP. Let's start. High-level data link control, or HDLC, is a bit-oriented protocol for communication over point-to-point and multi-point links. It implements the stop-and-wait ARQ protocol we discussed earlier. Although this protocol is more a theoretical issue than practical, most of the concepts defined in this protocol is the basis for the other protocols such as the PPP and the Ethernet protocol. HDLC provides two common transfer modes that can be used in different configurations: normal response mode or NRM and asynchronous balance mode or ABM. In normal response mode, the station configuration is unbalanced. We have one primary station and multiple secondary stations. A primary station can send commands, a secondary station can only respond. The NRM is used for both point-to-point and multi-point links. In ABM, the configuration is balanced. The link is point-to-point, and each station can function as a primary and a secondary. This is the common mode today. To provide the flexibility necessary to support all the options possible in the modes and configurations, HDLC defines three types of frames: information frames or I-frames, supervisory frames or S-frames, and unnumbered frames or U-frames. Each type of frame serves as an envelope for the transmission of a different type of message. I-frames are used to data link user data and control information relating to user data. S-frames are used only to transfer control information. U-frames are reserved for system management. Information carried by U-frames is intended for managing the link itself. Each frame in HDLC may contain up to 6 fields: a beginning field, an address field, a control field, an information field, a frame check sequence field, and an ending flag. In multiple frame transmission, the ending flag of one frame can serve as the beginning flag of the next frame. The flag field contains the synchronization pattern 0, 1, 1, 1, 1, 1, 1, 0, which identifies both the beginning and end of the frame. The address field contains the address of the secondary station. The control field is 1 or 2 bytes used for the flow and error control. The information field contains the user's data from the network layer or management information. The frame check sequence field is the HDLC error detection field. The control field determines the type of frame and defines its functionality. If the first bit is 0, it is an I-frame. The bits called the NS is the sequence number of the frame. The last 3 bits, called the NR, is the acknowledgement number when piggybacking is used. The PF bit has a meaning only if its value is 1. It means Paul when the frame is sent by a primary station to a secondary. It means final when the frame is sent by a secondary to a primary. The frame is an S-frame if the first 2 bits are 1 and 0. The code part will be discussed later. The frame is a U-frame if the first 2 bits are 1, 1. The code part will also be briefly discussed later. Here are the 4 possible control codes for the S-frames. Here are the possible codes for the U-frames. Here is an example of a flow diagram of a connection and disconnection. Node A will send a U-frame to B with a control code of 11100, which is a set asynchronous balance mode command. Node B will send to Node A a U-frame with a control code of 00110, which is a unnumbered acknowledgement. Here, Node A will send to node B a U frame with a command code of 00010, which is a disconnect command. And node B will send to A U frame with a 00110, which is another unnumbered acknowledgement. Here is a flow diagram of piggybacking without error. Node A will send to node B an iframe with a sequence number of 0 and an acknowledgement number of 0. Again, node A will send to node B an iframe with a sequence number of 1 and an acknowledgement number of 0. In response, node B will send to node A an iframe with a sequence number of 0 and an acknowledgement number of 2. 2 because the next frame it is expected to receive is 2. Again, node B will send to node A an iframe with a sequence number of 1 and an acknowledgement number of 2. Again, it will send to node A an iframe with a sequence number of 2 and an acknowledgement number of 2. Here, node A will respond to B an S frame with an RR and an acknowledgement of 3. Here is an example of piggybacking with error. Node B will send to A an iframe with a sequence number of 0 and an acknowledgement number of 0. Again, node B will send to A an iframe, the sequence number of 1, and acknowledgement number of 0. However, this frame will get lost. When node B sends to A an iframe with a sequence number of 2 and acknowledgement number of 2, it will be discarded by A. Then A will send to B an S frame of a reject command with a knock of 1 because it's still expecting frame 1 to B. So B will resend to A the iframe with a sequence number of 1. Also, it will send again to A the iframe with a sequence number of 2. Here, node A will send to B an S frame with a control code of RR with an acknowledgement number of 3. One of the most common protocols for point-to-point access is the point-to-point protocol, or PPP. Today, millions of internet users who need to connect their home computers to the server of an internet service provider use PPP. Majority of these users have traditional modem. They are connected to the internet through a telephone line, which provides the services of the physical layer. But to control and manage the transfer of data, there is a need for a point-to-point protocol at the data link layer. The designers of PPP have included several services to make it suitable for a point-to-point protocol. PPP defines the format of the frame to be exchanged between devices. It also defines how two devices can negotiate the establishment of the link and the exchange of data. It also defines how network layer data are encapsulated in the data link frame. It also defines how two devices authenticate each other. It provides connection over multiple links. It also provides network address configuration. PPP does not provide flow control. A sender can send several frames one after another with no concern about overwhelming the receiver. PPP has a very simple mechanism for error control. A CRC field is used to detect errors. If the frame is corrupted, it is silently discarded. The upper layer protocol needs to take care of the problem. Lack of error control and sequence numbering may cause a packet to be received out of order. PPP does not provide a sophisticated addressing mechanism to handle frames in a multi-point configuration. PPP uses a character-oriented frame. Here shows the format of a PPP frame. A PPP frame starts and ends with a 1 byte flag with a bit pattern. 011111110. The address field in this protocol is a constant value of all ones, which is a broadcast address. The control field is also constant with a value of 00000011, imitating the unnumbered frames in HDLC. The protocol defines what is being carried in a payload. The payload is user data or control information. The frame check sequence is a 2-byte or 4-byte standard CRC. Since PPP is a byte-oriented protocol, the flag in PPP is a byte that needs to be escaped whenever it appears in the data section of the frame. The escape byte is 0111101, which means that every time that flag light pattern appears in the data, this extra byte is stuffed to tell the receiver that the next byte is not a flag. A PPP connection goes through phases which can be shown in a transition phase diagram. The transition diagram, which is a finite state machine, starts with the dead state. In this state, there is no active carrier at the physical layer and the line is quiet. When one of the two nodes starts the communication, the connection goes into the established state. This state, options are negotiated between the two parties. If the two parties agree that they need authentication, then the system needs to do the authentication. Otherwise, the parties can simply start communication. The link control protocol packets are used for this purpose. Several packets may be exchanged here. Data transfer takes place in the open state. When the connection reaches this state, the exchange of data packets can be started. The connection remains in this state until one of the endpoints want to eliminate the connection. In this case, the system goes to terminate state. The system remains in this state until the carrier is dropped, which moves the system to the dead state again. Although PPP is a link layer protocol, it uses another set of protocols to establish the link, authenticate the parties involved, and carry the network layer data. 3 sets of protocols are defined to make PPP powerful: the Link Control Protocol or LCP, 2 Authentication Protocols or APs, and several Network Control Protocols or NCPs. At any moment, a PPP packet can carry data from one of these protocols in its data field. Note that there are 1 LCP, 2 APs, several NCPs. Data may also come from several different network layers. The Link Control Protocol or LCP is responsible for establishing, maintaining, configuring, and terminating links. It also provides negotiation mechanisms to set options between the two endpoints. Both endpoints of the link must reach an agreement about the options before the link can be established. All LCP packets are carried in the payload field of the PPP frame, with the protocol field set to C021 in hexadecimal. The code field defines the type of LCP packets. There are 11 types of packets as shown here. Authentication plays a very important role in PPP because PPP is designed for use over dial-up links where verification of user identity is necessary. Authentication means validating the identity of a user who needs to access a set of resources. PPP has created 2 protocols for authentication: Password Authentication Protocol or PAP and Challenge Handshake Authentication Protocol or CHAP. The Password Authentication Protocol is a simple authentication procedure with 2-step process. The user who wants to access a system sends an authentication identification, usually the username and the password. The system checks the validity of identification and password and either accepts or denies the connection. When a PPP frame is carrying any packets, the value of the protocol field is C023 in hexadecimal. The 3 PAP packets are Authenticate Request, Authenticate ACK, and Authenticate NACK. The first packet is used by the user to send the username and password. The second is used by the system to allow access. The third is used by the system to deny access. The Challenge Handshake Authentication Protocol or CHAP is a 3-way handshaking authentication protocol that provides greater security than PAP. In this method, the password is kept secret it is never sent online. First, the system sends the user a challenge packet containing a challenge value, usually a few bytes. The user applies a predefined function that takes the challenge value and the user's own password and creates a result. The user sends the result in the response packet to the system. The system does the same. It applies the same function to the password of the user, which is also known to the system, and the challenge value to create a result. If the result created is the same as the result sent in the response packet, access is granted. Otherwise, it is denied. CHAP is more secured than PAP, especially if the system continuously changes the challenge value. Even if the intruder learns the challenge value and the result, the password is still secret. CHAP packets are encapsulated in the PPP frame with the protocol value C2P in hexadecimal. There are 4 CHAP packets: challenge, response, success, and failure. The first packet is used by the system to send the challenge value. The second is used by the user to return the result of the calculation. The third is used by the system to allow access to the system. The fourth is used by the system to deny access to the system. PPP is a multiple network layer protocol. It can carry a network layer data packet from protocols defined by the Internet: OSI, Xerox, DECnet, AppleTalk, Novel, and so on. To do this, PPP has defined a specific network control protocol for each network protocol. One NCP protocol is the Internet Protocol Control Protocol, or IPCP. This protocol configures the link used to carry IP packets in the Internet. The value of the protocol field in hexadecimal is 8021. This ends Module 14. Thank you.